Right now, while you read this, there's a machine flying through space that is older than the internet, older than cell phones, and older than most laptops ever built. It has been flying for 49 years straight. It has not stopped once. And in the next few weeks, NASA is going to try something on this machine that has never been tried before, on any spacecraft, ever. If it works, this machine gets to keep talking to us for years longer. If it fails, it goes silent forever, and we lose the only working tool humans have ever built that can actually touch the space between the stars. This is not science fiction. This is happening right now, in real life, 13 billion miles from where you're sitting. And almost nobody is talking about it. You have probably heard of Voyager 1. It is the famous one, the one with the golden record, the one that is the farthest thing humans have ever built. But Voyager 1 is not the machine I am talking about. There is a second Voyager, its twin. And what this second spacecraft found when it crossed into deep space did not just confirm what its famous sibling found years earlier. It broke the story wide open. It found things no scientist expected, using a tool its twin lost decades before anyone even knew it would matter this much. Here's the part that makes this whole thing so strange. Both spacecraft flew past nearly the same kind of boundary, using almost the exact same equipment, built by the exact same team of engineers. You would expect them to find pretty much the same thing when they got there. They did not even close. By the end of this video, you're going to understand why this quiet, less famous spacecraft might actually be more important than the one everyone knows. And you are going to understand exactly what NASA is risking right now to keep it alive a little longer. Section 1, the twin nobody talks about. Let's start simple. Back in the summer of 1977, NASA built 2 robots and sent them out into space. They looked almost the same, both about the size of a small car, both loaded with the same kind of instruments bolted onto their sides, both given more or less the same job: fly past the giant planets, take pictures, and then just keep going until the edge of the solar system runs out. One of them left first. Its name was Voyager 2. It launched on August 20th, 1977. 16 days later, a second rocket lifted off. This one carried Voyager 1. Here's the strange part. Even though Voyager 2 left the launch pad first, it got stuck with the number 2. That is not a mistake. NASA gave the numbers based on which spacecraft would finish its main job first, not which one launched first. Voyager 1 was given a shortcut. It would fly past Jupiter and Saturn, then take a fast lane straight out of the solar system, skipping the rest of the planets completely. Voyager 2 got the long road. It would fly past Jupiter, then Saturn, and keep going all the way out to Uranus, and then all the way to Neptune. No other machine humans have ever built has done that. Not before Voyager 2, and not since. To this day, it is still the only spacecraft to ever visit all 4 giant planets in our solar system. Along that long road, Voyager 2 collected some genuinely bizarre trophies. At Uranus, it found a planet tipped almost completely on its side, spinning more like a rolling ball than a top, and it spotted 10 brand new moons that nobody on Earth had ever seen before. At Neptune, it clocked winds ripping through the atmosphere faster than any wind ever measured anywhere else in the solar system, strong enough to make the worst hurricane on Earth look like a light breeze. And on Neptune's largest moon, a strange icy world called Triton, it caught something shooting straight up into the sky. Tall geysers of freezing gas blasting several miles into the thin air, coming from a moon so cold that scientists still are not totally sure how it manages to stay active at all. Every one of those discoveries alone would have made Voyager 2 a legend. But the biggest discovery of its entire nearly 50-year life was still years away, waiting at the very edge of the solar system. But that longer route came with a price. It took time. A lot of time. Voyager 1 reached the true edge of the solar system, the very last bubble of space where the sun still has any pull at all, back in 2012. Voyager 2 did not get there until 2018, 6 years later. For 6 whole years, only one spacecraft was out there in that strange in-between region, sending back readings that confused scientists more than they helped them. And here is something almost nobody tells you when they talk about this story. Voyager 1's most important tool for understanding that region had already been broken for more than 30 years by the time it got there. We are going to get into exactly what that tool was, and why losing it left such a huge hole in what scientists actually knew in just a moment. But first, if this kind of thing gets your brain buzzing, go ahead and hit subscribe right now, because this channel is where you are going to hear about the results of what NASA is attempting with these 2 machines the moment it happens, not weeks later, after everyone else has already moved on. We follow this story in real time, and trust me, it is about to get a lot stranger. Section 2, the piece that went missing. Every spacecraft is really just a toolbox with wings. Voyager 1 and Voyager 2 each carried a set of instruments, and you can think of them like different senses. One instrument worked kind of like an eye, taking pictures. Another worked kind of like an ear, listening for waves of energy passing by. And one very special instrument worked a bit like a thermometer and a scale mixed together. It could measure how hot the gas around the spacecraft was and how thick or thin that gas was, both at the same time. This one tool matters more than almost any other tool on board, because the entire point of Voyager's later journey was to find the edge of something scientists call the sun's bubble. Our sun does not just shine light out into space, it also blows out a steady wind of tiny charged particles in every direction all the time. This wind pushes out so far that it actually forms a giant bubble around our whole solar system, bigger than almost anything you could picture using a normal comparison. Somewhere, way out past the last planet, that wind finally runs out of push. The bubble ends, and beyond it is a completely different kind of space, filled with leftover material from stars that exploded millions of years ago. To get a feel for just how big this bubble really is, think about it this way. Earth sits close to the sun, just one small step away in cosmic terms. Even Neptune, the farthest official planet, is a long way out. But the edge of the sun's bubble sits far past even that, roughly 4 times farther from the sun than Neptune itself. It took Voyager 1 and Voyager 2, spacecraft flying at tens of thousands of miles an hour, more than 3 decades each just to reach it. That is how enormous this bubble actually is. Our entire solar system, every planet, every moon, every asteroid you have ever heard of, is just a small speck sitting near the very center of it. The edge of that bubble is the single most important line in this whole story. Scientists needed that special thermometer tool to actually measure what that edge looks like up close from the inside. Here's the problem. On Voyager 1, that tool broke. It stopped working all the way back in 1980. That is not a typo. It broke before Voyager 1 even reached the edge. It broke before Voyager 1 even made it past Jupiter on its way out of the solar system. It broke 32 years before Voyager 1 finally crossed into deep space in 2012. So when Voyager 1 made history and became the first human-made object to leave the sun's bubble, it made that history blind. Scientists could still guess what was happening using its other tools, the ones that measured magnetic fields and cosmic rays, but they could not get a direct reading of the one thing that mattered most. It was a bit like trying to figure out how hot a stove is just by staring at it from across the room instead of actually touching it. Think about it this way. Imagine you desperately need to know if a lake is too cold to swim in, but the one tool you have for actually checking the water temperature is broken, and has been broken for years. You can still learn something. You can watch how fast leaves float across the surface. You can look at whether birds are landing on it. You can guess based on the weather that week. But none of that gives you the real number. None of that lets you dip your hand in and feel it for yourself. That is exactly the kind of gap scientists were stuck working around for 6 straight years, using every clever workaround they could think of, but never quite getting the one clean answer they actually needed. Some of Voyager 1's other tools still work just fine. One counted tiny high-speed particles zooming past the spacecraft. Another sensed the invisible tug of magnetic fields in the area. Both were useful, and both helped fill in part of the picture. But neither one could tell scientists the 2 numbers they wanted most, the actual temperature and the actual thickness of the gas right at the edge. For 6 years, guesses were all scientists had. Smart guesses? Built by smart people, sure, but still guesses. Then Voyager 2 arrived at that same kind of edge, in a totally different spot, coming in from a totally different direction. And its version of that special tool was still working perfectly. That is the exact moment everything changed. That is the moment the quieter, less famous spacecraft suddenly became the most important machine in the entire mission. Because for the very first time in human history, we finally had a direct, real, touch it and measure it, reading of what the edge of our solar system actually feels like from both sides at once. To understand just how wild what it found actually was, we need to slow down and walk through it step by step, because none of it matched what scientists were expecting. Section 3. The edge that should not exist. When Voyager 2 crossed into deep space on November 5th, 2018, 5 separate teams of scientists studied its data and then published their results all on the very same day in the same major science journal. That almost never happens, when 5 different research teams all release their findings at once. It usually means they found something too big to sit on quietly. Here's the first shock. Scientists had always pictured the edge of the sun's bubble as a thin, sharp line, kind of like the surface of a soap bubble. You are inside it, then you pop through, and now you're outside it. Simple and clean? That is not what Voyager 2 found. Instead, it found a thick, messy zone sitting right at the border, stretching out roughly 100 million miles wide. And the strange part is where that zone actually was. It was not sitting on the inside, where the sun's wind lives. It was sitting just outside the edge in the area that was supposed to be completely different, completely separate deep space. Picture it like this. Imagine a fence is supposed to separate your backyard from your neighbor's yard. But instead of a clean, straight fence line, What you actually find is a huge patch of your neighbor's plants and dirt that has crept way over onto your side, mixing in with your grass for 100 feet before you even reach the real fence. That is basically what Voyager 2 found. Material from deep space had pushed its way inward, mixing with the edge of our solar system in a way nobody had predicted. Then came the second shock, and this one made scientists scratch their heads even harder. Voyager 1 crossed the edge back in 2012, during a time when the sun was very active and blowing out a strong wind. Voyager 2 crossed 6 years later, during a time when the sun had calmed way down and was barely blowing at all. If the size of the sun's bubble depended on how hard the sun was blowing, which is exactly what every model predicted, then the bubble should have been noticeably smaller by 2018 than it was in 2012. It was not. Both spacecraft found the edge sitting at almost the exact same distance from the sun. One of the lead scientists on the mission came right out and admitted it plainly. We do not understand why that is. When one of the top scientists on a 50-year-old mission says something like that out loud, that is not a small thing. That is a scientist telling you that something about how our whole solar system works does not match the textbooks. Picture a balloon that is supposed to puff up bigger when you blow harder into it and shrink back down when you stop blowing. That is basically what scientists expected the sun's bubble to do. Get bigger when the sun was blowing a strong wind and shrink back down when the wind died off. Instead, it was like measuring that balloon at two very different moments, one with a huge gust of air going in and one with barely any air going in at all, and finding out it was exactly the same size both times. That is how strange this finding really was. The third shock had to do with temperature, and this is exactly where that broken tool on Voyager 1 would have made such a huge difference if it had still been working. Voyager 2's tool measured the temperature on both sides of the edge for the first time ever, and the drop was far sharper than anyone expected. The gas just outside the sun's bubble came in somewhere between 30,000 and 50,000 degrees. That sounds insanely hot, but compared to the gas just inside the edge, which was sitting at tens of millions of degrees, it is actually shockingly cold. And here is the kicker. Before this measurement, scientists had only ever been able to guess that number using math and theory. Their old guess was off by about double. Right alongside that temperature reading came another number that surprised almost everyone. Scientists already knew that the wind blowing out from the sun gets thinner and thinner the farther it travels, kind of like how a spray of water from a hose spreads out and gets weaker the farther it flies from the nozzle. But when Voyager 2's tool measured the gas sitting just outside the edge in real deep space, it found something far thicker than expected. The material out there was more than 40 times denser than the thin solar wind right at the border. Space, it turns out, is not the empty, endless nothing most of us picture when we imagine it. Out past our sun's bubble, there is actually more stuff floating around per square inch than there is right at the edge of our own solar system. That single number flipped a very common assumption about deep space completely upside down. Then there was the fourth shock, and honestly, this one might be the strangest of them all. The edge leaks. Not in some poetic metaphor kind of way. It actually leaks. Voyager 1 had already noticed something odd on its way toward the edge, like little fingers of deep space material poking their way inward, ahead of schedule, before the spacecraft even got there. Voyager 2 saw something similar, but flipped around. A slow trickle of material from inside the bubble leaking outward into deep space, before it had even crossed over. Two spacecraft in two totally different spots. 6 years apart, both saw the same basic thing. Stuff crosses that border in both directions, all the time. It is not a locked door. It is more like a screen door that never quite seals all the way shut. One senior scientist working on the mission put it best. He said the Voyager spacecraft are showing us how our sun interacts with the space around it, not simply where the sun stops and something else begins. That one sentence completely changes how you should picture the edge of our solar system. It is not a wall. It is closer to a beach shoreline, where waves keep rolling in and out, and the line between wet sand and dry sand keeps shifting depending on the exact moment you happen to look at it. And here is the part that should genuinely worry you a little. That same spacecraft is running out of power right now, in real time, while you're hearing this, which brings us to the risky plan NASA is attempting this very summer just to keep it alive. Section 4, the power problem. At launch, back in 1977, each Voyager spacecraft had about 470 watts of power to work with. That might not sound like a lot, and honestly, it is not. It is roughly enough to run a couple of hairdryers. But every single year since launch, that number has dropped by about 4 watts. Slowly, quietly, without fail, for 49 years in a row. Here's the plan. Instead of shutting things off and rearranging power little by little, testing each change carefully before moving on to the next one, the team wants to flip almost everything at once. Turn some things off, switch on cheaper backup parts instead, and rewire how power flows through the entire spacecraft, all in one single coordinated move. Why do it that way instead of slowly and carefully? Because slow and careful is actually more dangerous here, not less. Whenever you change a spacecraft's power setup, there's a brief in-between moment where the system is not fully in its old setup and not fully in its new one either. That messy in-between moment can accidentally trigger the spacecraft's built-in safety system, which is designed to automatically start shutting things down the second it senses the power draw getting too high. The whole point of doing everything at once is to blast through that dangerous middle zone as fast as possible instead of sitting inside it while it happens. And here is what makes this whole thing feel like something out of a movie. Voyager 2 is so unbelievably far away that every single command NASA sends takes over 16 hours just to arrive. Then, if something goes wrong and engineers need to check on it, the response takes another 16 hours to come back. That means one simple back and forth, one question and one answer, eats up more than a full day every single time. There's no way to fix a mistake quickly. There is no backup plan if it fails halfway through. There's no second attempt. Whatever happens during that test happens. If it works, Voyager 2 could keep its remaining science tools running for at least another year, maybe longer. And if it works on Voyager 2 first, NASA plans to attempt this exact same risky move on Voyager 1 no earlier than July, with a real chance that the tool it had to shut off back in April could actually get switched back on. NASA chose to test this on Voyager 2 first for a simple reason. It currently has slightly more power to spare than its twin, and it sits a little closer to Earth. In other words, it is the safer place to try something this risky for the very first time. Right now, as you are hearing this, that test is either already underway or just about to be. And the outcome of it will decide whether the machine that quietly rewrote everything we thought we knew about the edge of our solar system gets to keep talking to us or goes silent for good. Section 5. Why any of this matters. There is no other spacecraft anywhere near the edge of our solar system right now. There is nothing being built to replace Voyager 1 or Voyager 2 either. No mission like this is funded, and no mission like this has even been fully designed yet. If both of these spacecraft go silent, the flow of real direct information from deep space stops completely, and it does not start back up again for decades, maybe longer than that. No other country has one either. No private company has one. There is not a single working instrument anywhere near the edge of our solar system besides these two aging machines. If you tried to build a brand new spacecraft today, aimed it at the exact same point in space, and launched it as fast as engineers could possibly manage, it would still take decades just to reach the point where Voyager 2 already is right now. That is the size of the head start these two spacecraft have, and that is exactly why every extra year we can squeeze out of them matters so much. Everything scientists still do not understand, like why the edge of the bubble sits in the same place no matter what the sun happens to be doing, or exactly how that strange leaking in both directions actually works, or what the true shape of our sun's bubble even looks like from every angle. All of that stays a mystery until some future spacecraft, one that does not exist yet, eventually makes the same trip and reaches the same edge. Here is the part that makes the whole story feel even bigger. Voyager 1 and Voyager 2 are sampling two completely different sides of that same bubble. Voyager 1 is out exploring one direction, and Voyager 2 is out exploring a totally different one. Almost like two scouts sent out from the same camp in opposite directions to map the edge of a forest nobody has ever walked through before. Scientists still do not know if our sun's bubble is shaped more like a ball or stretched out long behind us like a comet's tail as we drift through the galaxy. Every extra year, these two machines keep transmitting as another piece of that shape, slowly filling in one faint signal at a time. All of that came from the twin that almost nobody talks about, the one that took the long road, the one that kept a broken tool working long after its more famous sibling lost the exact same one. Right now, somewhere out in the freezing dark, 13 billion miles from where you are sitting, it is still out there, still sending its faint signal back home, still waiting on a risky one-shot experiment that will decide how much longer it gets to keep telling us its story. If this blew your mind even a little, do me a favor and hit like, subscribe, and turn on notifications. Because the second NASA confirms whether this test worked, we are covering it here first. Now here is my question for you. If you could ask Voyager 2 one single question before it goes silent forever, what would you ask it? Drop your answer in the comments. I read every single one. And if you want to go deeper on the golden record riding along on both of these spacecraft, I have got a video on that linked right here. See you in the next one.